Hey everybody, welcome back to another episode of AGI Geeks. We're here today with Chief Remote Sensing Engineer Pat North. Pat put together an awesome list of some of the things that you can do when you might be working at home. Pat, thanks for joining us. And you've got some
Thanks,
pretty
George.
cool stuff to talk about today.
Again, my name is Patrick North, and one of the things I do here at AGI is I'm the Chief Remote Sensing and Imaging Science Engineer. So what I do is, I think about imaging stuff all day long, every day. And my background was I used to work for the defense and intelligence industries, where I would do a lot of new business development, a lot of operations support, and a lot of internal research and development projects. And one of the things that I always had to do in those roles was really think creatively about, here's our normal operations, here's our normal contracts, what can we do in addition to that? And a lot of that would require really out of the box thinking. And very recently, now that a lot of folks are working from home, what I've heard is folks aren't sure what they're able to do when they don't have their normal networks, when they don't have their normal tools, and when they don't have their normal data. And I said, well, there's a million things that you can do just from that, background that I had, where there's a lot of different tools, a lot of different capabilities, a lot of stuff that you can work on from home using tools like STK and EOIR to get a whole lot done. So instead of just thinking about these million things that you can do from home, what I want to do is make a real extensive, detailed list of the types of things that you can do, so that anybody could take a look at this and say, oh wow, yeah, I could not only do a lot of the stuff I was doing from home, there's new stuff I could do from home. And if these tools help me get started right away, then I can start doing this today. I sort of started this long list and I broke them into categories. So there's 10 different categories of the types of things that I think folks should be able to do from home using our tools. And some of these categories are going to be applicable to lots of folks. Some folks, if you're only doing optical material design, then maybe only one or two categories are going to be most relevant to you. But the idea is, here's a long list of things that are very specific, very detailed, that I think, might just get you inspired to say, oh, wow, you know what? Maybe initially when I started thinking about this, I didn't think that we could do that type of stuff from out of the office. So, I've got about, 10 different categories of things that I was going to just run through.
We should do like some big dramatic drum roll, right? Because you did 101, so that's a pretty impressive number.
I wasn't sure how many I'd be able to get at first, but I thought, well, 101 sounded like a good target, so I started working towards that. So some of these might be a little redundant, but I think the idea is that each one of these is a very specific thing that, whether you're a big company, a small company, or you're just a student who has a really good idea, all of those folks can get access to these tools and start making progress from the comfort of your own couch. And you can start doing, you can start building billion-dollar designs from your couch using these tools today. I think the best place to get started is just, building entire imaging system designs and architectures and doing some analysis. So the first few things that I thought of were, well, with STK and EOIR, you can add satellites, you can add aircraft, you can add facilities, and you can just start putting sensors on each of these to do this list of things that you see in front of you. So, you can just start generating data and metrics, and you can start doing, band trade studies and optical payload parameter trades, and you can build really quick designs and start evaluating them immediately. And not only that, you can start to, with STK, have things moving around as you would expect them to. You can have moving satellites, moving aircraft, moving imaging targets, and you can start to look at all those dynamic factors in developing this imaging system design. So I thought this was a good, good top 10 list to start with.
Yeah, and we've mentioned this before, but it's worth mentioning again, is you can do a lot of this analysis that Pat is talking about with more generic or notional models if you don't have access to your restricted or otherwise unavailable models that you have when you're in the office.
Exactly. So for me, if I'm working on a proprietary system or a sensitive system, I can use representative data and say, you know what, I can't put in the exact parameters, I'd get in trouble, but I can say, I'm dealing with an optical system with an F number of about 20, and I've got this, rough focal length, and you can, again, you can talk to all your program folks to make sure it's okay to do some of this analysis from home networks, and you can get very representative data. In fact, if I just take one of these and say, I'm looking at vibration impact on image quality. Well, you don't need the power spectrum of your vibration, folks. If you have it, if that's available, you can input a power spectrum of your vibration, or you can say, you know what, I know it's in this ballpark, or I'm going to take a best and worst case scenario as an envelope. I'm just going to plug those in and start doing my analysis. You don't necessarily need your full blown, you know, data file. You can do a lot of this with notional data from home, or you can work on transferring that data that you can work with and start doing the analysis, generate some imagery, generate some metrics, and then you can either take that output and present that or put it into a proposal for new work, or you can take what you've learned and then start applying it to the networks that have the real data that you need to do this analysis on.
Right, like once you get back inside, you could burn your analysis to a disk, take it to your security folks. They'll scan the disk. You can get your stuff inside, and then you can add in some of those different or more realistic numbers as you need to.
Exactly. Yep. And if you're looking to work remotely, so if you can log in via VPN, you can always get this software installed on the system that you're going to be working with as well. So you know whatever split that you're doing, if you're just getting STK certified, if you now said, you know what, now's the time, I've got the bandwidth, I'm going to get STK certified, you can do very representative analysis during your certification even and say, I used a prototype design just for the heck of it. I've been thinking about it in the back of my head for a while. Now that I've got it started, I can either keep, if I like using STK and EOIR for the analysis, I can keep using those on my work network, or I can take what I've learned and just move that data over and say, hey, I've got a great idea. I want to talk to my customer, about the analysis I was able to do using these tools that are available. So you can design imaging systems, or you can say, how are those imaging systems operating? So that's the tasking, processing, and collection, the TC-PED types of chain. So not only can you use STK to drive where the targets are, where the systems are, but you can also say, hey, what is the trade-off if I change the integration time, or if I've been looking at a new image compression algorithm, or if I'm playing around with a new type of tasking processing algorithm or architecture. Well, you can do a lot of that simulation again with STK and EOIR, so you can come up with those what ifs for the tasking and collection side of the equation. So you don't necessarily need to have everything to the nth level of detail. If you have an idea in mind, say I want to come up with a new a new operational tool. Like I want to have a thumbnail generator for my images as they come along. How am I going to get how am I going to get the raw imagery data for my system? Well, you can say I can generate synthetic data, and I can do a day in the life of a system, whether it's an actual system that you can get all the parameters for, or a notional system. I'll just add a LEO Earth imaging satellite, and I'll take pictures for a few days, and I'll add a few targets of interest. Well, then you can generate all that synthetic data, and then say, all right, now I can pretend that this was my ops data, and I'm going to just work on creating that visualizer from from my home computer, and then I can get it the way I want. I can maybe tweak the parameters a little bit. Then I can say, all right, now I could take this and try. Again, I had all the synthetic data here on my home network. Now I want to do some of this. I want to move my tool that I developed to my to my target network, my work network, and I can actually start implementing things faster. I think if you can get a lot of this data from accessible from home. And again, this is stuff that works out of the box, so I don't need to wait a week or two tweaking the parameters. I can download STK and EOIR, and I can start saying, all right, here's what would happen with this new tasking paradigm, or with this new set of collection parameters, or here's the data that I might want to process differently with my ops processing algorithms. Not only can you do the system simulation, the tasking and processing simulation, but now, we've got some interesting targets to look at. And lots of folks have used EOIR in the past to do this target analysis. So if you're looking at target-centric stuff, and I was right in the middle of a space debris study at work when I had to get sent home, and now I can't get to the database that I was using. Well, with EOIR, you can set up a lot of very specific target parameters to get some of the data that you might have been looking at. So, for example, you can specify the thermal characteristics. If it's a multi-material object, for example, we've done ANSYS simulations, which is the fluid thermodynamics calculator, to get the temperature over time of the skin of an aircraft that's moving very quickly, for example. We can have temperature varying. We can also have very small or sub-pixel targets. We can have attitude that might be subpixel. So perhaps you just see certain things happening at the subpixel level to tell you something about something that's a very tiny target. So, and also you can include your own material specification. So, for example, we're just going to say we're a spectral imaging system, and I've got unique materials I'm trying to identify, or I'm trying to do a very minute temperature variation. You can add a temperature profile onto objects, things like that. So again, you've got the whole system, you've got tasking and processing, and now you've got target-centric stuff, if that happens to be what you're doing. Now that you've got all these things that you can model and simulate, well, what do you do with it? Well, this is where I have fun, and I start writing image exploitation algorithms. So again, whatever type of image exploitation algorithm you're working on, or maybe you're just an image analyst and you have a concept for enhancing imagery that you're going to be looking at, you're going to actually putting eyeballs on. Well, you need that test data. So whatever you're doing with that data, you need to provide that type of test data. And what I'm telling you now is that STK and EOIR can get you that test data. So you can say, I don't need to worry about transferring data around or trying to get representative data, or maybe I'm working with a system that I haven't even used before, so I don't even have test data from that particular system. Well, if you can generate it synthetically, then you can start to actually process it. And that's the key to get you started. And again, whether you're looking at unique target characteristics or system characteristics, or just a new concept for tasking and collecting, once you've got that simulated, now you can say, all right, now I'm going to start working on the algorithms that are going to be taking advantage of it. Or I'm going to be having actual image analysts putting their eyes on a new product that you're going to be generating. Another area that you can look at too, so you always have nominal conditions. Well, there's a whole lot of variation that can happen. What can go wrong when you write the perfect image processing algorithm? Well, reality can happen. So another thing that you can start to take a look at is extreme atmospheric conditions, or a really cluttered background, or clouds are in the way, or you've got time of day, seasonality types of variations. All those things you can model with STK and EOIR as well. So for example, if I was in the middle of a sensitivity study and I said, our system can only operate under this range of conditions, well, you can start to generate metrics, you can generate simulated data, or you can actually put eyes on data from a system and show these envelopes of conditions and see where you're going to be able to operate and where you cannot. So again, you can look at your systems, you can look at the way you collect, you can look at the targets of interest, and you can also look at everything in between, the atmosphere, the thermodynamics, the characteristics that happen within a scene that might not be nominal. Also, one of my favorite things to do is anytime you have a new system or you're going to be integrating a new component into that system, you've got a lot of initialization and calibration tasks that you need to do. So you have a laundry list of things that need to be prepared ahead of time before you're going to turn a system on for the first time. And a lot of that's going to be exercises. Maybe you're going to be creating calibration algorithms or techniques or processes. So all of that new system, new component types of stuff, you can generate test data for, and you can start exercising those tools, exercising those techniques, exercising the ops floor that's going to be running this stuff. So all of that testing or preparation work, you can generate data for from home using STK and EOIR as well. Another aspect of imaging systems, imaging analysis too, is the systems engineering side of things. Again, that's a lot of creating requirements, validating requirements. So a lot of that requirements work where you're going to be taking high-level system requirements, you're going to be generating them, and you're going to be validating them, and you're going to be feeding that down to lower and lower levels. And to do a lot of that, I like to have a central type of simulation that everybody can sort of agree on and say, that's good enough, I can trust that they've derived these requirements from here, and that's going to be driving my requirements as a subsystem or as a system integrator. And one of the nice things with having a tool that can integrate data from a lot of different sources is you can have folks say, I might not have this data yet, but here's something representative. Or, if this turns out this way, then I can proceed making these assumptions. And that's what a lot of the system engineering is going to be based on. And this is a really nice setup for folks to say, let's create that whole systems engineering V using, simulate test data to sort of validate along the way. The parts that we can validate using STK and EOIR, let's start fast tracking those. So we can write requirements earlier. We can drive down the bottlenecks and say, if this is the real driving factor, then here's my critical path. And I've got to make sure I stay on that critical path. But you know what? If I can find out there's slack somewhere early on, then all of a sudden, if something isn't going to meet a spec value, we at least know that earlier so that we can start creating alternative paths, or we can figure out what the ramifications might be downstream for the rest of the folks involved in that system. Then let's just say you're in a laboratory environment and you've got the world's greatest new optical component, or you've got a new detector concept, or you've got a brand new piece of hardware that you're interested in getting into the image processing pipeline. Well, one of the ways to demonstrate what your new component can do is putting it into context. So you can take your new quantum efficiency curve, plug it into an existing system architecture with STK and EOIR, and you can say, here's the difference between chip A versus chip B, with optical prescription A versus B. And those let you take all the hard work that you're doing in the lab and expand it to say, here's the essential data that we need to get out of this system. Here's what it looks like now. Here's what it looks like with my new component that I'm fabricating, or I'm dreaming up, and it's maybe a real low TRL level, but it's something that's going to be a game changer if we can start to actually engineer this product or component or produce it in quantities that we need it practically. A whole other aspect too that I like, especially right now, is you can use STK and EOIR for visualizations real time. So if you have a demonstration that you're doing, if you had an event that you're trying to recreate for decision makers, if you're just trying to explain the fundamentals for how imaging systems or a new exploitation algorithm work to someone, a nice way to do that is to be able to plug it into a real-time capability that you can demonstrate with everybody in the room, or over VTC now, right? And you can show, here's what this parameter means, here's what it looks like in context, or here's what happened on the ground, and maybe it's a field test, and we saw this phenomenology, here's why. And you can plug in the target characteristics and show, here, if the target was doing this, this is what we would see with this imaging system, or this is what the algorithm would spit out, and here's why it worked, or here's why it didn't work. So once you start bringing other decision makers or other folks that might not be a technical expert in this area into the mix, the better you can explain what's happening to them, the more stake they can take in the decisions that you're coming to. I really like when somebody who might not have a background in imaging science at all can say, I understand what you're doing, I understand why this is $10 million more expensive, and I get it. I can now make a good, educated decision along with you, because you've been telling me we need to do this, but I now see it and I can get it and I understand it. The last few categories were really domain specific. A lot of these are generic and applicable to a lot of different industries, a lot of different domains. But there's some that in particular, I was like, if I was doing, launch monitoring, and I'm at one of the fields that we're actually, going to be launching rockets, and I want to make sure everything's going okay, or maybe I'm a missile defense type of application, here's some of the specifics for, hey, if I'm in that industry, these are the types of things that I'm doing, and I can actually do that from home. And it's, again, we can use notional data with STK and EOIR, and you can have, a lot of this phenomenology show up, and we'll get you there really quickly, and then you can keep upgrading the fidelity of the data that you have and the sensor models that you're using, but you can get up and running right away for these types of missions.
So, Pat, let me ask you right there. If you've gone through a lot of different things so far, if people want to get spun up on some of these topics that you've already run through, what's the best way for them to do that?
So one of the great things is we have agi.com/EOIR has a number of these pre-recorded webinars where we go through exactly this. So I know for the point source target signatures, we created a whole rocket launch that showed if you had a field measurement of this particular launch, what would it look like? And could I put it in context and view it from different types of sensors? And absolutely, the answer is yes, you can do that. And we have about, I'd say, a half dozen or more recorded webinars. They're about an hour long. They're led by a system engineer who knows this domain. And they walk through, hey, here's the buttons that you click, here's how to bring up an SDK scenario, here's how to add this type of object, and here's how to add a sensor to take some pictures or collect some data on this type of, target of interest. Tom Neely is our Aviator developer for SDK, and he loves being able to add sensors to his scenarios. He can build the latest and greatest aircraft engagement type of scenario, but what does my broad area thermal sensor see? What does the seeker on this particular object see? What does it look like to the sensors involved? And for the optical sensors, it's as easy as taking that scenario that's already been built and adding the sensors and the characteristics and the target parameters, and all of a sudden you've got now a new avenue of analysis that you can do on that existing scenario. Again, for SSA, for space situational awareness, if you're looking at chain of custody, or if you're looking at neighborhood searches, or if you're looking at closely spaced object types of scenarios, all that data you can generate, again, just using STK and EOIR, and start generating, if I'm going to have an alert go off, if, something starts leaving its box, well, how do you do that? Well, I can start generating the test data, and I can start writing the exploitation algorithms, or I can plug in notional systems that would collect on that data, and it's very representative, so you can start working, again, just with these few COTS tools that you can get on any network. And then I think I've got a few more, again, some ground imaging specific examples where I'm doing, I was in the middle of a material identification task, or I'm doing site monitoring, and I've got all my MATLAB code and I'm running it, but I just don't have that stream of input data as readily available. Well, again, if you wanted to build up a site model and you wanted to add targets of interest coming and going, or you wanted to add unique target characteristics or phenomenology, you can do a lot of that with STK and EOIR, so that you can keep working, again, from home. You can prototype your MATLAB algorithm. You've got representative notional data with STK and EOIR, and then when it's ready to go, or if you're writing a brand new proposal on it, you can put it all together and then bring it to where it needs to go, and you haven't wasted a day doing it. And then I think the last example I included, this is a great tool as well if you're doing scientific missions. So if you're doing near-Earth object detection, or you're looking at asteroid mission planning, we've had folks come to us with a lot of neat, unique missions, and because STK and EOIR are very flexible, you can build up it's incredible. The flexibility of the tools give you the capability to do just about any type of mission. And again, whether it's the perfect fit for it, or it's just it's pretty close but it's not quite there. Again, just knowing that these capabilities are out there gets you to the point where you can start to say, all right, now I've at least got a capability from home that I didn't know about before, and maybe it's 90% of the way there, or you know what, this is good enough for me to start running with today.
Wow, you got all the way to 101. Great job. That's awesome. You
Thank
really
you.
did. You really did cover a lot of topics, and it's also interesting. You covered the entire lifespan of a program. You talked about some of the things before program starts, as well as much later in the life cycle of the program, and you really did cover a lot of different domains and applications. So. Quite a bit you covered in that short amount of time right there. And again, if you have trouble with this stuff, you can always reach out to our support department. Check out that link that Pat mentioned earlier. And there's other videos on how to get started with your at-home use licenses, or you can use STK Cloud. You can get a trials license. It's also a really great time to get certified in STK if you have some time where you don't know what to do. Get certified in STK. There's virtual trainings, online trainings, and take that knowledge and apply it to these problems that Pat has talked about here in this video.
Yeah.
Pat, did you have anything else to add? Like you already didn't add enough? 101 ways.
So something fun that I thought would be neat too is, so I just ran through this list of 101 different items. However, if I was watching this and I was skeptical, I'd be like, well, I want to see him actually do something. So pretty soon we're going to be having STK 12 release. So I thought it'd be fun to say, I'm going to put this list in front of the system engineers, and if anybody is watching this from home or from work and you're like, I want to see him do this one, I'll actually take whichever items that we've seen on this list as feedback, and I'll focus the next STK 12 focused demo or webinar that we do on those topics that get the most response. So I don't want to just show that there's a long list of things that you could do. I'd like to actually show that, hey, no kidding, you can actually do these and put this into practice. So I'll see whichever of these gets the most feedback, and I'll make sure that I create a demonstration myself showing that you could do this from home right now with the hardware that you have, and you can start getting back to work right away doing these really, really critical things that we need folks to be able to work on, all the time, every day. So again, don't let any of the lack of access to systems, data, networks, stop you. If you've got a great idea, if you've got a critical thing that you're working on right now, don't let these things hold you up. Let's, help you get started so that you don't lose a minute getting those good things done.
Awesome. Thank you very much, Pat. You heard him, folks. Get your feedback in. We'll see what we can do to give you some more specific, deeper examples of everything that he just talked about here.
All right. Thanks, Josh.
All right. So long, everybody.
All right. Take care.